Hi there. For this video, we'll be discussing how to expand logarithms. So basically, this is like the reverse of what we did in the previous video, wherein we simplified large logarithms. But similarly, we'll be needing to recall the laws of logarithms for this. So again, if we have a logarithm of a product, we can split it into two through addition. If we have a division out here, we can split it into two as well, but in terms of subtraction this time. Then, if we have raised to a power, we can move that to the side of the logarithm, so it will be out here. And lastly, we have the change of base formula, wherein if we have this one and this one out here, we can split it into these two logarithms, wherein they are splitted by division. So take note of these laws as we go on through our examples. So let's have this first example. There. Let's have this first example. So in this example, our goal is to simplify, or rather expand, this logarithm out here, the logarithm of 4 square root of 3 in terms of x and y. So let's work on that one. So we have here the logarithm of 4 square root of 3. So first, by the first law of logarithm, we know that since these two are a product, we can split them up. So we'll have here the logarithm of 4 plus the logarithm of square root of 3. Now, from here, note that we can express 4 as 2 squared, and we can express the square root of 3 in terms of 3 raised to 1/2. Therefore, we'll have the logarithm of 2 squared plus the logarithm of 3 raised to 1/2. And by the third law, we can simply move the exponent here out here, and we can move this one out here. So we'll obtain 2 logarithm of 2 plus 1/2 logarithm of 3. And what do we have here? We have logarithm of 2 and logarithm of 3, which we know to be simply x and y by our given. Therefore, we can write this one out as 2x plus 1/2 y. And we are done. We had already expressed the given logarithm in terms of just x and y. So, this one out here is our final answer. So there. Let's have this second example. For this one, our goal is to expand this logarithm out here, the logarithm of 125 with respect to base 9, provided that a is equal to ln 3 and b is equal to ln 5. Sorry for that. So, let's start with the logarithm of 125 with respect to base 9. So what can we do with this one? Again, our goal is to make a and b appear. But unfortunately, we don't have ln's out here so far. But by the change of base property or law, since we have 125 and 9 out here, we can express this one as the logarithm of 125 all over the logarithm of 9. And the good thing about change of base formula is that we can choose the base of the logarithm out here. Since our goal is to have ln, then we can simply let this bases be e. Since the logarithm of e is simply ln. So we'll have here ln of 125 over ln of 9. Now from here, we still don't have ln of 3 and ln of 5. But note that 125 can be written as 5 cubed and 9 can be written as 3 squared. Therefore, we can write this one as ln of 5 cubed all over ln of 3 squared. And by the third law, we simply move this exponent out here. So we'll obtain 3 ln of 5 over 2 ln of 3. And now, we already have ln of 5 and ln of 3. So we know that ln of 5 is simply b and ln of 3 is simply a. Therefore, we can write this one now as 3b over 2a. And we are done, since we had already expressed our given in terms of a and b. Let's go on to this last example. Our goal for this one is to expand this logarithm out here in terms of m and n. Okay, so, oops, I forgot. There should be, let's move this. There should be an a out here. There. And there, we're ready to solve this one. So first we have the logarithm of 49 over 36 with respect to base a. So how do we solve this? Well, since we have division out here, then we can split that one up into the logarithm of 49 with respect to base a minus the logarithm of 36 with respect to base a. And then from here, we note that 49 is simply 7 squared. and 36 is simply 6 squared. So we've got the logarithm of 7 squared with respect to base a minus the logarithm of 6 squared with respect to base a. And again, by the third law of logarithms, we simply move this exponent out here. So we'll obtain 2 logarithm of 7 with respect to base a minus 2 logarithm of 6 with respect to base a. And now observe that these logarithms out here are already the given. Therefore, we can simply write this one as 2n minus 2m. And this one out here is the answer for this problem, since we had already expressed the given logarithm in terms of m and n. So observe here that even though we don't know what a is, or the base a, we were still able to get the answer just by using the laws of logarithms. So I hope by this time you had mastered the laws of logarithms, since it's very useful when you encounter logarithms, whether in expressions, equations, or even functions. So to end this one, here is an exercise that you can work on. So for this one, your goal is to expand this logarithm out here in terms of alpha, which is the logarithm of x with respect to base 3, beta, which is the logarithm of y with respect to base 3, and gamma, which is the logarithm of z with respect to base 3. So seeing this problem might seem overwhelming at first, since there are a lot of variables in it. There's x, y, z, there's even alpha, beta, and gamma. But if you follow the same process that we had in our examples, this exercise is pretty straightforward. And also as a hint, the outcome out here is 3 terms. So it will be this one plus this one plus this one, like that. So take a look at this one as we're about to end this video. So yeah, feel free to comment down below your answers and solutions to these examples, especially this last exercise out here. And yeah, I hope you enjoyed this video and you learned a lot from it. So that's it, and that is all for this video.